Hello guys, hope you all doing well. In this video I'm going to solve the problem of the day from Code Studio, and today's problem is find the lone set bit. Let's get started. It is saying you are given a single non-negative integer n whose binary representation consists of single one digit means set bit and rest of the digits are 0. Your task is to find the position of only one digit, the position of only one digit. In other words, your task is to find the position of only set bit in the binary representation of input integer n. We'll be given an integer n, and we have to find the position of 1 in its binary representation. The position of set bit must be counted from least significant bit. Now what is this least significant bit? It is the bit from rightmost bit. Means if a number is like this 0 0 1 1 0 0 1, then this bit rightmost bit is called least significant bit, LSB. We have to start counting from here, and this will be our 1th bit. If the count of the set bits in the binary number is not equal to 1, then your function should return -1 as input. Alright, so here we have to do two things. First, we have to return the position of set bit. Before that, we have to do one more thing, that is we have to find out that if given number has only one set bit. First we will do that. This first point we will check that if the given number has only one set bit or not, because if it is having more set bits than one, then we don't have to find the position of set bit, we will simply return -1 in this case. So we'll first check if it has only one set bit or not. Then if it has only one set bit, then we'll try to find out its position. Now let us see this point, how we are going to find out if it is having only one set bit or not. We'll find out using the property of bits that you must know if you have learned about bit manipulation, that any number that is n has only one set bit if it is a power of 2, some power of 2. Means if n is equals to 2 to the power x, where x can be 0 1 2 3 anything. Let me prove this fact. What I am saying that any number which is a power of 2, such as 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, all these number in their binary representation will have only one set bit. This is 1, this is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16. Now what is the binary representation of 1? Binary representation of 1 is 0 0 0 0 1, and binary representation of 2 0 0 0 1 0, binary representation of 4 0 0 0 0 0 1 0 0. You can notice that all numbers here have only one set bit. And what is the binary representation of 8 0 1 0 0 0, and binary representation of 16 1 0 0 0 0? All these numbers have only one set bit. Now how will you confirm that these are the correct binary representation of these decimal numbers? We we do that by writing, starting from the 1, multiply 1 by 2 and write it below the next bit, that is 2, and again multiply it with 2 and write the result below the next bit, that is 4, again 8, then 16. Now our answer will be, our decimal number will be sum of all these numbers above which set bit is present. Here only one set bit is present above 16, so the decimal equivalent of this binary number will be 16, which is here. So they are the correct binary representation of these decimal numbers, and they have only one set bit. Now we have to, you must have understood, now we have to find that given number is power of 2 or not. And there is one more property related to this. If any number power of 2, n is any number which is power of 2, and if I perform AND operation which the number just below it, means a number just less than it by 1, will give me result 0. Always it is going to give me result 0. In the other case, if it is not a power of 2, in other it is never going to give me 0. Let me prove it. Let me take a number. Let's take 8 1 0 0 0 and minus 1, it is 8. 8 minus 1, 7. Binary representation of 7 is 0 1 1 1. It always happens that if we subtract 1 from a number which is power of 2, so the 0 bit in that number will become 1, and only set bit will become 0. This always happens. And if we perform AND operation here, bitwise AND operation, then as all corresponding bits are different, so we'll get result 0 for each bit. You must know that AND gives 1 when both the bits are 1. Here in neither of the bits, both bits are not 1, so we'll get result at as 0. So we'll check through this formula. We'll check if it is power of 2 or not, if it is having only single set bit or not. We'll check through this formula. Now after checking this, if it comes to be 0, then we'll find out the position of only set bit. You must notice here that we are given an integer number, and we know that integer number is 4 byte in size, and it is equivalent to 32 bits. It is going to have only 32 bits, so our answer will be from 1 to 32 only. Our answer will lie in this range only. So I am going to put a for loop from 1 to 32, and I'm going to check each bit. As it is only having one bit, I am going to check each bit if it is set or not, and at any point when I will find this set bit, I will return this current iteration of this for loop, and I will check through the XOR operation. I will put 1 here below every bit in the given number, and I will perform XOR operation. And we know that XOR operation gives 1 when both are different, 0 1 or 1 0. We'll get 1, and in other case 1 XOR 1, 0 XOR 0. In the case of same bits, it gives 0. So it is the whole number will become 0 when our 1 is below the set bit in given number. Here only at the first position set bit is present, so our whole number will become 0. Here all bits are 0, same bits, same corresponding bits are same, and this bit in which set bit is present, it will also become 0 because I am doing here XOR operation with my 1. Now let's see the code, and it will become more clear to you. As discussed, first we will find out if it is power of 2 or not. So for this I will perform a bitwise AND operation as I have discussed between n and n minus 1. If it is not equal to 0, means this number is not a power of 2, and I will return minus 1. I will simply return minus 1 here, and if it is not the case, then I will move further and I will try to find out the position of that only single sad bit. I'm going to run here a for loop from 1 till 32, and I will put here a if condition. If n and bitwise XOR with 1 left shifted by ith position minus 1 is equals to 0. Don't worry, I am going to explain what is happening here. Then I will return I, and here I have to return anything, as this function returns integer, so I will return here minus 1, and this condition will never reach because we will find our set bit here only. Now what I am doing here, I am doing this left shift operation for moving this one. Suppose we have a number, suppose we have 8, which is in binary form, which is 1000. So what I am doing here with left shift operator, first it will be left shifted by 0 position, it will lie here. You see here, initially I is 1, 1 minus 1 will become 0, so 1 will be left shifted by 0 position, means it will be at the starting bit, that is least significant bit, and I am going to perform here XOR operation. Definitely it is not going to be 0, as you know that here the bits are not same, it will come 1 and it will also come 1, and this result will be a non-zero number. So it will be a non-zero number, so this if condition will not execute, and I will not return anything here because I have not found a set bit till now. I will return the bit position only when this one will come here. So one will come from here, and I will shift it by one position more, then it will come here, then it will come here, and when it will come here, they will become 0. And now if I perform XOR operation, all the corresponding bits are same, so result will be 0. Here this condition will become true, as result is 0 now. Now I will return the position of the bit, which is the ith bit. So this is it, this is the code, and it should work. Let me try to run it. Yes, it is working. Let me try to submit it. Yes, all the test cases are passed, it is working absolutely fine. Hope you like the video, and I'm going to see you in the next video. Till then, bye bye, take care.